Hello dear students, welcome to our channel. I am your maths teacher CG ma'am. Today we are going to discuss about chapter 2 polynomials. Okay, the word polynomial is very familiar to us, isn't it? Okay, what is a polynomial? It is a special type of algebraic expression. Okay, algebraic expression. Algebra comes, okay, we are very familiar with that is variables and constants. Okay, if you are writing an algebraic expression, definitely we will make use of variables and constants. Understood? Okay, what is a variable? Variable means it has no fixed value. Okay, the value of that variable changes from problems to problem. Okay, but constant means it has fixed value. Okay, if you are going for a shopping and if you are asking for taking 5 mangoes, if you are going to another state, okay, that we are getting, if we are asking 5 mangoes, we are getting the same number. Okay, that means this 5, 10, 100, all these are said to be constants. Okay, so variables usually we are representing with small letters of English alphabet like C, Y, okay, X, okay, P, all these are said to be variables. Okay, so and its value changes. Okay, but constants have fixed value. Okay, as I told, polynomial is an algebraic expression. Okay, and it shows the sum of monomials. What is its meaning, children? A polynomial is an algebraic expression that shows sum of monomials. Okay, and I told if you are taking simply a constant, okay, constant itself a polynomial. If I am taking a single variable, x is also a polynomial. Okay, so it shows the collection of monomials, the sum of monomials. What is its meaning? Okay, that is sum means addition. Okay, that means if I am taking, see children, a variable x. Okay, and I am taking one constant and I am adding these two. Okay, so x is a monomial. Okay, another monomial is 5. Okay, they are connected by plus sign and we know that only plus and minus sign separates terms, isn't it, children? Only plus and minus terms. Okay, see children, if I am writing 5x, okay, we can't see any plus or minus sign between them. That means it is a single term, but it is a polynomial. Okay, see children, x plus 5 is a sum of monomials. See children, x is a monomial and 5 is also a monomial. So, it is the sum of monomials. Okay, and also you can see that I have used only a single variable. Okay, so we are talking about polynomials in single variable. Okay, and how can we name a polynomial? See the variable used in it. Okay, if I use the variable x, you can represent that polynomial by p of x. Point is clear, children? Okay, p of x indicate it's a polynomial with the variable x. Okay, again come to that number of terms. Okay, so it consists of two terms. As I told, only plus or minus sign separates the term. So, x plus 5. Okay, so this polynomial p of x has two terms. So, children, see the first sentence, a polynomial is an algebraic expression that shows the sum of monomials. I hope the idea is clear. Okay. See children, what else we have discussed in the previous classes? Okay, that means we know the polynomial and by definition it is, I think that idea is clear. Okay, and secondly, we have discussed about its degree. What is the degree of a polynomial? Okay, degree of a polynomial. Okay, for example, I am writing another polynomial with the variable x. Okay, see children, here I am going to write another example of polynomial, that is p of x is equal to ax square plus bx plus c. See children, P of x is equal to ax square plus bx plus c. Here you can see that, okay, in the RHS, okay, three terms. Ax square is the first term and its coefficient of x square, that means a. And see the second term, since they are connected by plus sign, so this plus sign separates terms, okay, bx from the first term ax square. So second term is bx with the variable x, that is why I used p of x, okay. So bx, okay, c, its coefficient is b, and plus c, that is c is a constant, it is free from the variable. Okay, so I am going to explain what is degree of the polynomial. See children, in this given polynomial, you can see in two terms the variable x, and see that the power of each variable. Okay, here in the first term x, its power is 2. Here in the second term, variable is x and its power is 1. Okay, and the highest power of the variable in the given polynomial is what we call the degree. The highest power of the variable. Okay, so here ax square. Okay, so that term having the highest degree compared to the second term bx. Okay, so the degree of this polynomial p of x, okay, degree equal to 2. That means this 2 is nothing but the power of the variable, the first term. That means the variable, the highest power of the variable in the given polynomial. That is what is degree of the polynomial. That concept is clear children. So degree of the polynomial is nothing but the power of the highest power of the variable in the given polynomial. And another one children, I am giving another example, and I am giving the general form of a polynomial. Okay, so in p of x, okay. So and secondly I am giving you a polynomial. See, ax cube plus bx square plus cx plus d. See the second example. Okay, here I have used the same variable, that is x itself, but see the first term, that is ax cube. Here a is the coefficient, b is the coefficient of x square, here a is the coefficient of x cube, and c is the coefficient of x, and d. So see children, in the first case also a, b, c are any real number. Okay, but in the second case we have one more term, 4 terms. Okay, 1, 2, 3, 4. So a, b, c, d, all these 4 can be any real number. Okay, see the power of the first term, that is 3. Here x square, that is 2. Here cx 1, and d is a constant term. Okay, see in these two cases I have arranged the terms in the descending order of their degrees. See the variable and its power, and I have arranged in a special manner. Okay, so that you can easily write down the polynomial, or you can place the terms of the polynomial in the correct position. What is the condition? You should arrange either in descending order or ascending order based on the degree. See the highest degree, that term should come first. Okay, that is about the polynomial. Okay, so see that what is the degree, and accordingly you can arrange the terms. That point also clear children? Okay, and the next one. See, in all these two cases, see the power of the variable. It must be always a whole number. See 2, 1. Here 3, 2 and 1. Okay, that means it is compulsory that the power of each term must be a whole number. That is the another very important thing. Understood? Okay, from this we are getting a very important point. You can take a monomial, but if you are taking a monomial, that is a constant, okay, that variable cannot be in the denominator. But listen children, what I said, if you are taking a polynomial, that is p of x, okay, that means if you are taking x or by y, it cannot be possible. Okay, this is not a polynomial. Or even if you are taking a constant, okay, 2 and x, if you are writing x in the denominator, what happens, children? We know that 1 by, see, what is this 2 by x? 2 can be written as 2 into 1 by x, isn't it? 1 by x. What is 1 by x? Is nothing but x raised to minus 1. See, children, so this can be written as 2 into x raised to minus 1. See the power of x. Here the power of x is not a whole number. It is a negative number, negative integer. So that is why I told this cannot be a polynomial. We cannot represent this as p of x. Why? Because here the variable x comes in the denominator. That is very, very important. So make sure that the variable and its power of each term must be a whole number. This is another important condition to become a polynomial. Okay, so first you see that in that polynomial, how many terms. Based on that, you can name the polynomial, you can categorize, you can classify the polynomials. Okay, and see how many, what is the degree of the polynomial. Okay, these are the very important points. How many terms, what is its degree of the given polynomial. Okay, with regard to the degree, the power of each term must be a whole number. That point is clear, children? Okay, that is the variable cannot be in the denominator place. Okay, these are the very, very important basic things. So, what all things we discuss? The definition of a polynomial. Okay, polynomial is a algebraic expression. It may consist of variables and constants. Isn't it, children? Okay, and it can be the sum of monomials. Monomial is, that means if we are separating the terms plus or minus, then only it will contains more terms. Okay, if simply as a variable x means it is a single term. Okay, if we are writing along with the x with the plus sign, we are writing a constant. Now then it becomes 2 terms. Okay, and the another point is, see the variable, that is see the polynomial, whether it is arranged in ascending order or descending order. Okay, otherwise you have to arrange in descending order or ascending order. That doesn't matter, but it would be better to write in descending order. Okay, and see that the power of each variable is a whole number. Okay, and the coefficients a, b, c, d or whatever it is, that is the term containing the first term x square term, its coefficient. Okay, it can be any real number, that doesn't matter. What I meant is, see children, p of x is equal to root 2x square plus 5. Doesn't matter. Here root 2 is in place of a, that is coefficient of x square. That is a, coefficient of x square is a, isn't it? So it can be any real number. Real number means rational number or irrational number. It doesn't matter. But what is very important, the power of the variable must be always a whole number. Whole number, why I said whole number? Because every constant number, that is constant term, can be represented as, see children, if you are taking 5x, what is the degree? That is 5x means x to the power 1. Okay, if I am writing simply at the term 5, what is the degree? And 5 is definitely, it is a constant polynomial. Okay, it is free from the variable. Okay, so 5 can be written as x to the power 0. Okay, we know that a to the power 0, its value is 1. So x raised to 0. Okay, so its value is 1. Okay, that means here the power of x is, the variable x is 0. So that is why I use the term whole number. 0 includes that set is what we call whole number. So that point is clear, children. Now see the second one. See, a monomial is an expression in which variables and constants may stand alone or be multiplied. Okay, that means you can take the example of C2, monomial. This is a monomial. Okay, see, in which variables and constants may stand alone. See children, what about x? It's another monomial. Okay, here the constant stand alone, here only variable or multiplied. You can multiply a constant with a variable. Another example, that is 2y. Here what I did, I have taken a number 2 and a variable y and I multiplied. So we got another term, another monomial. Okay, that is 2y. 2y means it's a single term. It's a monomial. Okay, so it's very important point. A monomial is an expression which in which variables and constants may stand alone or be multiplied. Understood? Okay, and monomial cannot have a variable in the denominator. Okay, that explanation also I have given. A monomial cannot have a variable in the denominator. See children, this is not a polynomial. 2 is a monomial, but if you are writing x in the denominator, it is not a polynomial. Why? Because 2 by x is 2 into x raised to minus 1. Here the degree of x is minus 1, is not a whole number. It is a negative integer. Understood? Up to this point is clear? Okay. And as I told, I have shown already by taking an example constant polynomial, it can be represented with the polynomial to the power 0. That is 5 into x 0. 5 is a constant polynomial. This can be written as p of x because I have used x along with the 5. Okay. Hence, you can say that the degree of the constant 5 is 0. Likewise, if you are taking any constant like 100, okay, 100 can be written as 100 into y raised to 0. So, you have to represent this with p of y. So, what happened here children? Here also the constant polynomial, its degree is 0. That means the degree of a constant polynomial is always 0. That point also clear children? Okay. Now, take 0. 0 is a constant. 0 polynomial. 0 polynomial. Okay. And its power is not, not power, its degree is not defined. So, the degree of 0 polynomial is not defined. Understood children? Okay. So, polynomials can be classified based on number of terms. Okay, as I told, only plus or minus sign can separate the terms. Okay, so we have monomials, binomials and trinomials. Okay, see, even if polynomial, that is the word polynomial, that is poly means many and nomial means terms, but still, that is many terms, but still monomial is also a polynomial. That is why it includes in that category. Okay, but very important that it must have only a single term. Okay, either a constant itself or a single variable. Okay, both are correct. If you are representing with a constant, it is a monomial. Okay, simply a variable, that case also it is a monomial. If you are writing these two together with a multiply sign, that is 2x or minus 7x or 8y, all these are monomials. Okay, and see children, monomials I have taken 3x minus 5x cube, and third example is 2x. Okay, all these are different monomials. Okay, understood. And the second is binomials, that is y square plus y. See, here I have used the sign plus. This plus sign separates this y from the first term y square. So, it has two terms. So, a polynomial with two terms is what we call binomial. So, hence here, since the variable is y, you can represent that with p of y is equal to y square plus y. This one. This can be represented by p of y. Why? Because here the variable is y. See children, y raised to 50 plus 1. In this case also, you can see two terms. Y raised to 50 is the first term and the second term is 1. This case also you can represent with p of y. The variable is y. And the third example, the third type is trinomial. Trinomial means triangle, three sides. So tri means 3. Okay, that means 3 terms, x square plus x plus 5. So this is a trinomial. And more than 3 terms, we simply use the word polynomial. A polynomial having 4 terms, 5 terms. Okay, that doesn't matter. It can have any number of terms, but simply we are using polynomial. Okay, so these are the 3 very important names based on the types of polynomials based on the number of terms. Okay, and the second one is that polynomials also classified based on degree. What is degree? The highest power of the variable. Okay, see the each term and its power, variable and its power. Okay, see children, so they are linear polynomials, that is 3x plus 2. Okay, linear means 1, the power is 1. So 3x plus 2. In that case, you don't look into don't count the number of terms. We are just concentrating upon the power of the highest power of the the term in the given polynomial. Okay, so here 3x and 2. So in the first term 3x, the x is the variable and its power is 1. And the second term is 2, it's a constant. So its power is 0, and I already told the degree of a constant is always 0. Okay, so among this the highest power is 1. So if a polynomial with degree 1 is what we call linear polynomial. Okay, and the second type, that is a polynomial with degree 2. Okay, see children, quadratic polynomial, 2x square plus 5x minus 2. See here you can see 3 terms. Okay, see each variable and its power. Okay, here the first term, its variable x and its power is 2. Okay, and in the second term, the power of x is 1. Okay, and constant power is 0. And among this, the highest power of x goes to the first term. Okay, so it is, and its power is 2, so it is quadratic polynomial. And the third type, that is cubic polynomial. See, I have taken one example. First term x cube plus 3x square minus x plus 2. Okay, see the first term and its power, the variable x and its power is 3. Second term, the power of x is 2. Power of x in the third term is 1 and constant, so its power is 0. The degree of constant is 0. Okay, so among this the highest power of x is 3, so hence it is called cubic polynomial. Understood? So in this year we are discussing mainly quadratic and cubic polynomial. A polynomial of degree 4, 5, that doesn't matter. When we are dividing, we may have take these examples of polynomial of degree 4 or 5. That doesn't matter. That time I will explain how that can be divided and all. Okay, so children, this is all about the classification of polynomials based on number of terms and degree of the polynomial. That part also clear? Okay, so what is zeros of a polynomial, children? Okay, so to explain the zeros of the polynomial, I am giving an example, that is p of x is equal to x minus 2. Any polynomial you can take. Okay, so I am going to substitute here the value of x as 2. Let us see what happens. Okay, that means, which implies p of 2 I am going to substitute in place of the variable. 2 is a constant, we cannot make any change in the constant term. Okay, so this is equal to 2 minus 2, that is 0. 2 minus 2, 0. Okay, if I am substitute the value of x in the given polynomial other than 2, let us see what will happen. For example, I am taking a number that is minus 1. Okay, so p of minus 1 when x is equal to minus 1. So minus 1 minus 2 is minus 3. We can't make any change for the constant term, and I already explained we can give we can give the value 4 or substitute only for the variable. Okay, so we have minus 3. What is the difference, children? If I substitute value of x in the given polynomial as 2, we got the RHS or P of 2 equal to 0. That means the value of the variable by which the polynomial equation becomes 0. This P of x become now 0. So 2 is that value of the variable is called the 0 of the polynomial. But here in this case, minus 1, when we substitute x as minus 1, we didn't reach into 0. Okay, that is we got minus 3. That means minus 1 is not a 0 of the polynomial P of x is equal to x minus 1. Understood? Okay, that is the meaning of zeros of a polynomial. Okay, so children, I am giving a another important point from this point. Okay, how the graph of a linear can we call this is a linear polynomial? Why? Because its power is 1. Okay, I am going to draw the graph of this linear polynomial. Okay, now we are going to discuss the graphical representation of the polynomial. That is P of x is equal to x minus 2, that is linear polynomial. Okay, based on the degree, we have linear polynomial, quadratic polynomial and cubic polynomial. Okay, so first I am giving explanation for graphical representation of linear polynomial. Okay, so children, so we need solutions. Okay, that is for that we have this type of box. Okay, and here we need x value and y value. Okay, for plotting a graph mean we should get x coordinate and y coordinate. Okay, here children, x coordinate means the value which we are going to substitute for x. Okay, and here P of x we are writing y. Y is actually P of x. Okay, so this can be written as y in the form y is equal to, I am going to take the value of x as 1 minus 2. If you substitute 1 in the given equation, you will have minus 1. Isn't it? 1 minus 2 is 1 plus minus 2, that is minus 1. That is y we got as minus 1. So you can write here minus 1. Here you can write, yes, x we have taken 1 and minus 1. Okay, and we definitely you can take x when x is equal to 2. Okay, so 2 we have already have seen, that is we got y as 0. Y P of x, here x means y, P of x means y. Y equal to 0 when x is equal to 2. Yes, I am going to plot the graph for this. Okay, so for that we have x axis and y axis, 0 the meeting point origin. Okay, 1, 2, here comes minus values. Okay, minus x axis, here positive 1, positive 2. Okay, minus 1, minus 2. Okay, 1 minus 1, here it comes. 2 and 0, y is 0, 2 comma 0 on x axis. If you join these 2 points, okay, if you extend this y axis, you can see that it's a straight line. We know the linear equation, the graph of linear equation is always a straight line. Understood? So, here this graph touches the x-axis. Okay, at the point, what is the coordinates of this point is 2, 0. Okay, this is very important point, children. Okay, after plotting the graph of the given linear equation, we have seen that its graph touches the x-axis at the point 2, 0. Or through that graph, by simply looking into the graph, you can say what is the 0 of this linear equation. That exactly the x coordinate of the point of intersection of the graph with x-axis. X coordinate, see the point 2, 0, and in 2, 0, 2 is the x coordinate. So that will give the x coordinate will give you the 0 of the given polynomial. Okay, and also the very important thing, a linear polynomial has at most one zero. That means the number of zero decides the degree of the given polynomial. Linear polynomial means its degree is 1, hence it has only one zero. That point is clear, maximum 1 0. Why it is maximum 1 0? It cannot go more than 1 because the highest power is 1 since it is linear. So it can be 0. Number cannot be negative, children. So the only possibility is maximum, if I use the word maximum, 0 or 1. When it has no zeros. That means we know that in the last year, if y is a constant, the graph is parallel to x-axis like this. This is a graph of y is equal to 2. Okay, so see children, since the parallel means there is no common point between x-axis and the graph. In this case, but this is a y equal to 2, is a linear equation. Can we write this as y minus 2 equal to 0? Definitely. So its power is 1, so it is a linear equation. But since the graph is parallel to x-axis, in that case, even if the given polynomial is a linear, okay, the graph is not touching the x-axis. That means no zeros. Understood? So, but in this case, you can see that this graph is touching the x-axis. So, x-coordinate of the point of intersection of the x-axis with the graph gives the precisely the value of its 0. The point is clear, children? This is all about the graphical representation of linear polynomial. What is the second type? That quadratic. Okay, if we have the quadratic polynomial, since suppose I am taking p of x is equal to x square minus 2. See children, very important. The graph of a quadratic polynomial, power 2, quadratic polynomial, graph of, quadratic polynomial, if you plot the graph, it is always either open upwards or open downward. It is not a straight line. And that graphical representation, that shape is what we call parabola. Parabola. Understood? That means this shape, like this or downwards. Okay, so that means if you plot the graph by giving different values of x, corresponding value of y you will be getting, and after plotting this graph, either its graph will intersect like this, or it may open upwards without intersecting the x-axis, or simply at one single point. Understood? So, or like this. These are the possibilities. Okay, anyhow, this shape is what we call parabola. Okay, see, if we are getting exactly of this shape, see that this graph intersect the x-axis in how many points? This point and this point. See, write down its coordinates. Okay, minus 5 or 0. Here, if I am giving not mark, but it is a negative x-axis. So, minus 1, 0. What are the x-coordinates? Here is minus 5 and minus 1. So, here we got two values, two x values. Why? Because this is a quadratic and its power is 2. So, a quadratic polynomial has maximum 2 zeros based on its degree. So, the number of zeros and the degree are that much connected. The number of zeros of a given polynomial, you can easily get it from its degree of the given polynomial. A polynomial having n degree, it has n zeros. 5 degree polynomial, it definitely has 5 zeros. Okay, now we are only talking about quadratic, so that is why its graph parabola intersected the x-axis 2 points, maximum, isn't it? Here see children, and also here you can see this graph open upwards. In that case the coefficient of x square, that is a, greater than 0. Understood? Here see children, here this graph, this parabola opens downwards and at the same time it intersects 2 points, so 2 zeros. Okay, but in this case the graph, the equation in this equation a is less than 0. That is minus x square minus x plus 2, like that. I just simply concentrated upon the coefficient of x square. Okay, this is also a quadratic polynomial and with a is less than 0. This is the shape in that case. Okay, then when we have this shape or this shape, one single point upwards, if we are getting equal zeros, when the parabola open upwards, in that case a is greater than 0 and downwards, in that case less than 0. That is clear children? Okay. Yes. When we have that one single point means, see children, p of x is equal to x square plus 4x plus 2, 4x plus 4. This is x plus 2 whole square. So x plus 2 into x plus 2, that is x is equal to minus 2 minus 2. That means 2 equal zeros. That is, in that case you can see the point is 2 comma 0, or here if it comes like this, minus 2 0. Okay, this point. So only 1 0. Okay, no distinct 0, only 2 equal 0. Okay, and when we have this type children, this parabola is not touching the x-axis, that means no zeros. So a quadratic polynomial maximum number of 0 is 2. It may be no 0, okay, if like this, okay. If it comes only in this form, it is not touching the x-axis. Okay, always see that children, the point at which this parabola intersects the x-axis, and see the coordinates and take its x coordinate. That will give you the zeros of the polynomial. If the parabola is not touching the x-axis, means it has no zeros. That is not factorizable. That is the mean that we will study later on. Okay. Anyhow, a quadratic polynomial has maximum 2 0. That is 0. It can be 1 or 2. In the same way, cubic polynomial. Cubic polynomial, the shape is not parabola. Okay. It will be of this type. So cubic means 3, isn't it? Okay. So it may be either like this. See children. So this graph is touching at this point, this point, this point. Understood? I mean, in this case it is touching only one point. Okay, it can be of this type. Okay, so these if we have the graph of a cubic polynomial of this type, see the number of points at which this graph intersected, 3. So in this case, this cubic polynomial has 3 zeros. And see the number of, understood, number of points where that graph get intersected. Like that you can count the, you can write down the number of zeros. Okay, so a cubic polynomial can have maximum 0, 1, 2 or 3. 3 is the maximum number of zeros for a cubic polynomial. Okay children, this is all about the graphical representation of zeros of the polynomial. Okay, this is enough for doing the first exercise. Okay, that is exercise 2.1. So children, please take exercise 2.1 from your textbook. Okay, you can see that the shapes are given. Okay, exercise page number okay, page number 28. See, the graph of y is equal to p of x, and I already explained y and p of x are same, given in figure 210. Okay, for some polynomials p of x, find the number of zeros of p of x in each case. See the first graph, the graph is parallel to x-axis, is not touching the x-axis, that means no 0. Okay, and the second graph, okay, that is the graph is touching only at one point. Okay, so it is a it has only 1 0. Okay, it is not a quadratic. Okay, it is the shape of a quadratic polynomial is always parabola, U shape. Okay, open upwards or downwards. And second one, 1, 2, 3 places. So it has 3 zeros. Number of zeros it is asked. Find the number of zeros. And the second one, of course, it's a quadratic polynomial, graph of a quadratic. So it has 2 zeros. It intersected at 2 distinct points. This is the answer for the fourth question. And the fifth question, 1, 2, 3, 4 points. See, the graph intersected at x-axis at 4 points. So it has 4 zeros. And next graph, last graph, 1, 2, 3. So it is also having 3 zeros. Okay, so this is all about exercise 2.1. Is it okay, children? So this is all about exercise 2.1 and the introduction part of chapter 2 polynomials. Thank you, children. Thank you everyone for watching and supporting my videos. Thank you all.